Hi, in this lesson we're going to talk about matrices. A matrix in mathematics is a rectangular array of numbers, and they are enclosed in brackets like the matrices you can see here. They're all enclosed in that kind of brackets, and each matrix consists of element. Every number you see here in this matrix is an element of this matrix. We also talk about the order or the dimension of a matrix. What do we mean by that? What we mean is the number of rows and the number of columns. So in this case, in this matrix here, we have a matrix of 2 by 2. That means 2 rows by 2 columns. This is a 2 by 2. This is a 2 by 2. That's 2 rows and 2 columns. And here we have a 2 by 3, where we have 2 rows. That's 1 row, and that is the second row. 2 rows and 3 columns. That's 1 column here, a second column, and the third column. So this matrix here, this is called a 2 by 3. That's 2 rows by 3 columns. And this one here, we've got 3 rows and 2 columns. So basically this is the order of a matrix, or the dimension. So when you hear the dimension or the order of a matrix, what we mean is the number of rows by the number of columns. We also talk about equality of 2 matrices. 2 matrices are equal if they have the same element. Like this one here has 6 elements, and this one here has 6 elements. They have 2 rows and 2 columns, both of them. All the numbers are equal. Then the x here must equal to 4, and the a here must equal to minus 2. So the element here, this position here, will be equal to the same position of the other element. Then in this case, x has to equal to 4, and the a has to equal to minus 2. We can add and subtract matrices just as long as they are conformable. What do we mean by conformable? We mean they have to have the same order. So if you're adding a 2 by 2, like this one here, a 2 by 2, 2 rows by 2 columns, the other matrix has to be of the same dimension. Got to be a 2 by 2. Then you can add them. You can add the element, the correspondent element together. Like you add the 3 and the 0, you add the 4 and the 6, you add the 5 and the 5, and the 6 and the 2. So you add the 3 and the 0 here, bring it to the same place, and you add the 4 and the 6 to the same corresponding element position, the 4 and the 6. The 5 here, you can add it to the 5 here, you get 5 plus 5, and so on. You add the last element, which is 6 and 2, and it will give you this a new matrix, which is equal to, this matrix equal to A plus B. This is matrix A, and that's matrix B, and that will give you a new matrix, which is here, and that is matrix C. And you can do the same. You can do the same with subtraction. You'll get another matrix here, and that is the answer. So you subtract the corresponding element, and then you should get the result should be of the same order. So you started with a 2 by 2, you've added or subtracted a 2 by 2, you should get a 2 by 2. That is a 2 by 2, which is 2 rows and 2 columns. A zero or a null matrix, what do we mean by that? If all the elements, null matrix of this order 2 by 2, all the element equal to 0. So all the element are equal to 0. In this case, this matrix will behave exactly like a 0. So it will add like a 0, it will multiply like a 0, and this is what we call a 0 matrix. Identity or a unit matrix is where you have the diagonal of the matrix starting with the first element equal to 1, and then all the numbers in the diagonal equal to 1, in this case like a 2 by 2 matrix, and then all the other element are equal to 0, so all the diagonal equal to 1 and all the other element equal to 0. In this case you have a unity matrix or an identity matrix, and this will behave like 1. You can multiply it and add it. It is denoted by I. I means a unity matrix, and this will behave exactly like the real number 1 in the number system, and it can be of any order, in this case 2 by 2, and this is a 3 by 3. So the numbers in the diagonal is the numbers are 1 equal to 1, all the element equal to 1 in the diagonal, and then all the other element of this matrix will equal to 0, and that is a unity. This is a unity matrix. So it can be of any order. It can be a 4 by 4, a 6 by 6, and so on. This is a unity matrix, and this is the symbol for it, an I. Transpose of a matrix, and it's denoted by a prime. What it means? It means that you take the row, you take this row like 1, 2, and minus 3, and that row becomes the column 1, 2, minus 3. Same with this one, the row is 4, 7, and 0. You make that into a column 4, 7, and 0. What you get is a transpose of A. So we started with a matrix equal to A of 2 rows, and 3 columns. You finish up with 3 rows and 2 columns, and that is a transpose of a matrix. You can multiply a matrix by a number, any matrix. You can multiply it by a real number, and the way you do that is this number here, for example 4, you multiply it by each single element of that matrix. So 4 times 2, then 3, 4 times the 3, 4 times 3, and 4 times 7, and 4 times minus 1. This is usually called a scalar. That number here, a scalar. When you multiply a matrix by this number, you get a new matrix, and that is the final result. It doesn't change it only changes the element value. It stays the same. We started with 2 by 2, 2 rows and 2 columns, and we finish with the same shape or with the same order. And in the same way, you can take a factor out. You can take a factor out. In this case here, you can take a 3 out. So the 9 divided by 3 gives you 3. 3 divided by 3 gives you 1, and so on. So we are not dividing the matrix, we are just merely dividing the element of the matrix. So we're taking 3 as a common factor, if you like. Matrix multiplication. You can multiply two matrices, and the condition are the number of columns of the first matrix has to equal the number of rows in the second matrix. I repeat, the number of columns of the first matrix, in this case 2 columns, must equal to the number of rows of the second matrix. Otherwise, they are not conformable. You cannot multiply them. And the way we multiply, we go that way and that way, that way and that way. So the A times the E, and then the B times the G, you add them together, and then you multiply the first row with the second column here. So the A times the F plus the B times the H, and that will give you this value here. And then you move to the next row, then you get the C times the E, the C times the E, the D times the G, the D times the G, and then you get this element here. And the last thing you do, this second row multiply by this column here, so you get the C times F plus the D times H, and give you that last value. Have a go at these examples yourself. Don't look at the answer, just multiply them, A, B. Yeah. When you get to the C, you have one column here, one column and 2 rows, and therefore this is not conformable. You cannot multiply it. The number of columns has to be equal to the number of rows. The number of column here is 1, and the number of rows here is 2. So these matrices here, it cannot. They are not conformable. Therefore, you cannot multiply them. Also, there is another property when you multiply. You know, multiplying A by B gives you one set of results. If you multiply it in the reverse, if you multiply this times the first one, it will give you another set of results. So AB is not equal to BA. It is said they are non-commutative. AB is not equal to BA. You can try the result yourself. You can multiply this in the usual manner. You'll get this 19, 22, 43 and 50. If you multiply B times A, if you multiply B times A, it will give you another set of results. It will give you a different matrix. So this is called non-commutative in the matrix multiplication. Now you should be able to attempt the exercise given, the exercise on matrices, exercise number 1. You should be able to do that and submit your work as a PDF on the Brightspace. And this is just a summary of what we said about multiplication. So you start with a matrix of 1 by 4. You multiply by a matrix 4 by 4. And it's only possible if the number of columns, here equal to the number of rows here. They must match.